Alright, in this video I'm going to talk about probability distributions. So here you have a coin, you're going to flip it once, and then you're going to flip it again. If X represents the number of heads you get from two flips, we need to create a probability distribution. I'll get to what the probability distribution piece is first. First thing I want to look at is I want to list out my outcomes. So we're flipping a coin twice. I want to list out what are the outcomes of flipping a coin and then flipping again. So what we could do is we could flip it and get heads on the first flip, and then get heads on the second flip. And then let's think what else could happen. Well, I could get a heads on the first flip, but second time I get a tails. Well, what happens if I start with a tails first? Well, I could start with a tails first and then get heads. Or I could do a tails first and get a tails. So I'm just listing out what are all the possible outcomes that can happen with flipping this coin twice. Now in our problem it says X represents the number of heads you get from the two flips. So let's figure out that. What X is the number of heads. So in this first outcome I could get two heads. I can get one. I can get one. Or I can get none. So kind of listing out the outcomes and counting up what our X variable is, I think really kind of helps us figure out what's going on. So the piece that we need to make is a probability distribution. And this kind of allows us to see probabilities in a table format. So you're going to have at least two rows to this. So we have an X row, which X represents the number of heads. I'm going to have that row. And then I'm going to have the probability of X, the probability of getting each of those X values. So what I'm going to do is I'm going to list out my X, which is the number of heads. And I'm going to list that from least to greatest. So I can have 0 number of heads. I have 1 listed twice, but I'm going to only write it once here. 0, 1, or 2 is the 3 different number of heads that we can come out with. So what this PX row signifies is what's the probability of X happening? So what's the probability that we get 0 heads? Well, if I look at my outcomes, well, how often do I end up with 0 heads? Well, it happens one time out of 1, 2, 3, 4 possible outcomes. So 1 out of 4 chance that we get 0 heads. And then let's move on to what's the probability that we get 1 head. Well, it happens with a heads tails and a tails heads. So it happens 2 times out of 1, 2, 3, 4 total outcomes, 2 out of 4. And then what's the probability that we get 2 heads? Well, it happens once out of 4 total outcomes. Other things with this probability distribution, you could represent, I put these as fractions. You could put them as decimals if you want. So if you want to put 0.25, 0.5, 0.25. One thing you'll notice, one characteristic here is this entire row should add up to 1. So 0.25, 0.5, and 0.25, that is 1. So this should always add up to 1. That's a good check to make sure, hey, is this correct? So this is my probability distribution with X up top and PX on the bottom. So let's use that to answer some questions. So according to the probability distribution, which I have here, what is the most likely outcome? Well, again, 0 is 0.25, this is 0.5, and 0.25. So what has the highest probability of happening is also the most likely to happen. Well, the highest probability to happen is this 0.5 right here. So we are most likely to get, well, likely to get 1 heads and 2 coin flips. And again, the reason for that is that was the probability that happened the highest, the greatest. So 0.5 is higher than 0.25 and 0.25, so getting 1 heads and 2 coin flips is the most likely outcome. So what is the probability of flipping at least 1 head? So flipping at least 1. You're going to have to pay very close attention to what they're asking. At least 1 means I can flip one head, because that's at least one, or I can flip two heads, because two heads is still at least one. So you got to be careful with that. So what's the probability of flipping at least, or flipping one head? Well, the probability of flipping one head is 0.5. And the probability of flipping two heads was 0.25. The only thing we have to worry about is that or in between. Remember, with probability, when we have or, that means we're going to add these together. 0.5 plus 0.25 is 0.75. If you would have done this with fractions, you would have ended up, by the way, with 3/4. So that is probability distributions.